Good morning. My name is Jeff Perry. I'm the president and COO of ProdataKey. I'm excited to be with you this morning. As we've learned over the last few courses on technical installation, it's really important, the topic that we're going to be discussing today, wire and wiring. I've got over 15 years of experience in the industry, both in technical and sales experience, and I'm excited to bring a little bit of that experience to you. My hope is that it brings real value to you and helps you understand how to properly wire and utilize proper wiring to deliver real value to your installations. A lot of this is behind the scenes, so it's much of what your customers won't see, but many times it's what they don't see that's most valuable to them. So keep that in mind as we go through this and really strategize on what's most valuable to you on the installation side and what will be most valuable to your customer as you really perfect your installations and make them a work of art, something that you can be proud of, and again, deliver real value to your customers. Just as a reminder, this is a live class. Questions are encouraged. If you'll just chat them in the YouTube chat on the right-hand side, we'll open up for a live Q&A at the end of this training. So because it's a live class, please forgive me if I misspeak, but understand that we're really excited to answer any questions, and again, really hope that you understand a little bit more about wiring as we get through this. It's really designed to help you improve, and all of us in the industry to improve our technical skills. So the first thing I want to review today, and something that we talked a little bit about in some of the previous courses, is different types of wire. So I want to point out a couple of different gauges of wire that we have. If you look at this slide, it's got everything from 22 gauge all the way up to 10 gauge. And as you look at the gauge of wiring, the smaller the number, the bigger the gauge, or the bigger the wire is. So if you were to get to 2, 3, or aught gauge, or 1 gauge wire, those are very, very large wires. So the benefit in wire is line loss as far as power is concerned. Also, when you're talking about connecting other devices, how much amperage can you pull through a specific wire, and a lot of that is determined by your wire run length, as well as the size of wire and how much resistance that wire can handle. In other words, if you were to use a very small wire in your home on AC or DC and pulled a lot of amperage or wattage through that wire, you could pull more amperage than that wire could handle, and that wire would act like a fuse. In other words, it would start to get warm, and the more amperage that you pulled, or wattage, it would even get to the point where that wire would melt. And once it melted, then that wire would obviously break apart and act as a fuse, and it would sever it. And in some cases could cause a fire. So some of this is cautionary, but also it's very important to make sure that you're installing the proper gauge wire for each of the applications or product that you're going to be installing, so you don't run into a scenario where your wire's getting too hot, you get way too much line loss, or issues with power at your edge or end devices. So we're going to talk a little bit about that. So wire gauge is very, very important. Please refer back to the power, our power course, and it will talk a little bit more about the different gauges of wire and line loss. And we'll talk a little bit more about that. And I'll show you that here in the next slide. But first of all, if we come back to this slide, you'll see that there's a website at altronics.com/public/calculators. This is a very, very important tool. Again, for every one of you, there should never be an excuse that there's not enough tools out there to accomplish your job the best that you possibly can. And as Dallin mentioned in the sales courses, it really is all about practicing your craft. And you can, with all of the tools that are out there and available, for us on the installation side, we can practice our craft as well and really understand what's out there and available to us. So make sure that you utilize these calculators that are available to you so you can calculate the size of wire that you need for the specific wire runs that you're going to be doing. On this slide, you're going to see just a general chart that shows how many feet you can run a specific gauge of wire and what the line loss will be on those specific wire gauges. So again, if you look at the previous slide, go to ultronics.com/public/calculators. It's a fantastic calculator, very dynamic, but there are also different types of graphs like this that will show you the different types of gauge wire that you can run at whatever feet that you're going to be running that. The last tool that I'll show you, and this is a tool that we send in our dealer kits. It's a tool that's provided by ASSA ABLOY. And again, it's the same thing. It shows you the different gauge of wires that you're going to be running, the distance and the line loss that you're going to experience based on that those wire runs. On the back of it, it also has battery backup calculator. So you can slide this based on how much battery backup and how much amperage you're pulling, and it will help you understand what size battery you're going to need for specific installations. So again, all of the tools are out there and available to you. All of these calculators are readily available for you. I know the ASSA ABLOY would be happy to send you one of these that you can just keep in your pocket or your tool bag that'll help you calculate those things as well. So keep in mind, they're available to you. There's really no excuse not to be great at what you do, okay? The first type of wire that I want to talk about is network connectivity. This is really important. We know that there's Cat5, Cat6, Cat5e, these different types of wire, and for the most part, these different types of wire are about data throughput and how much data you can transfer through those particular wires. So when you're looking at Ethernet and PoE, there's not a ton of difference in those. And for access control, there's not a ton of difference in running a Cat5, Cat5e, or Cat6 because access control is a very low data throughput. So if you're running a network connectivity, don't be super concerned on the type of wire that you run, other than there's nothing wrong with being forward thinking. And if there's a new connectivity method that's out there and available, it's always best to run the latest and greatest, right? I'm typically not going to run some of the oldest technology that's out there. But if you have a box of Cat5 on the truck or the van and you're running that to a door, I wouldn't be super concerned with that because, again, access control is very low data throughput, so it's not something that you're going to be super concerned with. There's not going to be issues with the amount of data that you're running. Now, if you're connecting a camera, and especially once you get up 1, 2, 3, 4, 5K, that type of thing, you're going to need a lot of data throughput. So the type of wire that you're going to be running and having more of a gigabit connection, Cat6 connection out to those particular devices is going to be super important. But when you're talking about access control, again, low data throughput, the type of network connectivity isn't as important as it would be if you're using a high throughput type of connectivity. Again, there's Ethernet and PoE. We talked a little bit about this in the power class, but I want to revisit a couple of these things. Ethernet is a connectivity, again, just that's going to communicate your data to your specific door controller, and I'm going to show you that here in just a moment. But PoE is going to pass power as well, and it's typically passed through at 48 volts, and you're going to look at your switch and determine how many watts are available per port. Now, one thing that's a big misconception in the industry is powering your different devices off of a PoE switch. Number one, most access control platforms don't power your devices or only provide a specific number of milliamps, maybe 250 milliamps of available power through PoE to your devices. So you want to make sure the controller that you're looking at, that you recognize how many total milliamps are available power for the ancillary devices that you're going to be powering. If you're powering PoE Plus, some of these devices provide additional power, but it's not as common as you might think that it is today. If you're utilizing ProdataKey, we do provide you a full amp and a half of available power as long as you're utilizing a PoE Plus switch at roughly 30 watts per port. Now, what's important to note there is regardless of using ProdataKey or any other panel, the total amount of wattage that you're going to be pulling from that switch, each switch has a total allotted wattage that's available. So again, it's 48 volts typically for PoE, and you're going to have a specific number of wattage or amount of wattage that's available on that PoE switch. So I may have a switch that's rated at a total of 100 or 150 watts. Now, if it's rated at 100 total watt output, and I've got 5 ports on there, and I'm pulling 30 watts per port, at 100 watts, I can really only plug in 3 devices before I'm at 90 watts. If I'm pulling a full 30 watts per port and I plug in a 5th or a 4th device, now I'm over allocating the wattage, especially if you take into consideration the increase of amperage, or in this case wattage, that's being pulled on an inrush of a strike or a maglock. So don't get caught into a scenario where you put in a PoE Plus switch and you think, oh man, it's PoE Plus, it's allocating 30 watts per port and I can plug 10 devices into it. You have to look at the total amount of allocated wattage for that port and understand that if I'm pulling 10 watts per port, I can get 10 devices plugged into it. But I need to look at my inrush or my total amperage or wattage that's being pulled at the spike and calculate all of my power based on that. I can't calculate it based on my resting wattage or amperage that's being pulled on devices. So again, PoE is very important. It's extremely valuable if it's done right. So make sure you look at total wattage that's available on the PoE switch. Make sure that based on the type of controller that you're plugging into it, that's a PoE Plus switch, and you're going to be very successful. Another thing that I want to point out that's very important when plugging in, Cat 5, Cat 6, or whatever it may be, is knowing that this type of wire has a specific run length. You can't just take Cat 5 or Cat 6 and run it as far as you want. You're going to get about 328 feet, which is the run length of Cat 5 and Cat 6. And that can be variable based on a few things. But ultimately, if you're running greater than 328 feet, then you need to plug into another device, like another switch or something like that, that's going to get you another 300 and some odd feet. So again, just make sure that if you're quoting out a project and you've got a run that's 500 feet, you may want to consider running a fiber optic cable, or again, putting a midspan or something in between that to boost your run length so that you can get out to that controller that you're going to be plugged into. Or put your controller at 300 feet and then run access control wire the remainder of that. So just be cognizant that as you're installing these products, that you don't just run them as far as you want, because there are limitations in how far that you can run Cat 5, Cat 6, etc. So hopefully that helps you understand network connectivity, run lengths, and PoE, which is a very important aspect of access control, especially as more controllers become more PoE enabled and are relying on that power. If your controller is PoE enabled and is still, regardless of the PoE connectivity, only providing you 250 milliamps at the door, and you're going to be pulling more amperage, then you do still have to provide a separate power supply for that controller. And that's always kind of boggled my mind, because it's never made a ton of sense to me to run PoE and have the additional cost of a great PoE switch, which those things can run anywhere from $100 to $5,000, depending on the type of PoE switch that you have installed. And it's a really expensive way to power access control if you're also coupling that with an additional power supply. So if you're running a Cat 5, Cat 6, you're plugging it into your controller, and then you realize you don't have enough amperage, you're providing a separate power supply as well. Now all of a sudden that installation became much more expensive than you may have anticipated. So in some cases it may make sense, run data only if you're pulling a lot of amperage and the controller's not providing you the amount of amperage that you need based on the PoE output, and just run a separate power supply. So keep that in mind as you determine whether you're going to run PoE or not. But more and more controllers are providing greater output for PoE, and I think that you'll find more success there as you move towards the PoE installations. So let's look at a little video at networking and connectivity into the controller. So you'll see in this instance, we've got a ProdataKey cloud node. We've got the Cat 5 or Cat 6 coming in. You're going to plug that right into the bottom of the controller, and immediately that receives connectivity. Now in this case, the cloud node is not PoE enabled, so you do need to power this with a separate device, but the cloud node is made to be mounted in a network closet. So it's not typical that that device would be PoE enabled. You typically just plug it in, has battery backup right there as well. And that's something to note as well that I failed to mention earlier, that when you're using PoE, your battery backup is going to come from your PoE switch. So you do want to make sure that the PoE switch is on a UPS, has battery backup that's there and available, and or then plugged into a generator. If it's plugged into a generator, then you've got as much time as is available for that for the fuel capacity on the generator. And typically your UPS is just your failover while your generator is ramping up. So keep in mind that if you're looking at battery backup in a PoE scenario, plug it into a UPS regardless of having a generator or not. Your UPS will need to have enough power to power all of your devices to get you the amount of battery backup that you need. If you have a generator installed, then it just needs to fail over long enough for that generator to spool up and take over the load. So keep that in mind as you're installing and you're looking at battery backup for these devices. So let's look at wiring a reader. There's a couple of different ways that you can wire a reader, and let me just show you on this, this particular wire here, and I've got a slide that will show it here in a second. But this is a typical reader wire. You've got your red and your black, which is providing power. You've got your white and your green that's providing data 1 and data 0. And then you've got your yellow, which is typically connected into a piezo buzzer or another ancillary device on the reader. Your brown is typically your LED trigger. So that's what changes the LED from red to green when you're allowed. And then you've got a couple of other wires here as well that are available. Your orange will trigger the green wire, and then your blue is a hold wire. So this will have all the wires that are available for most reader installations. And it's important to note that in most cases you're not going to utilize all of these, but you can based on the type of reader that you're installing. Another wire that you see coming out the side here is let me see if I can get this to focus, is just a bare metal wire. So this particular reader wire is what's called a shielded wire, and you can see if I bring this that I already have stripped out, this is the shield right here. It's almost like an aluminum wrapping that goes over, or a tinfoil wrapping that goes around the wire, and it protects your wire from getting ambient noise from other power energy sources where your wire may be running. So in most cases, every reader needs to utilize a shielded wire. It really protects it and protects you from having to go back out to an installation and wonder why a reader is not reading the correct data or isn't working correctly. And a lot of times that can be from ambient noise that's coming through your reader wire. Now, there's a lot of misconceptions here. A lot of individuals won't know what to do with this extra wire. That wire needs to be grounded. If it's not properly grounded to the reader and utilizing the shield wire that's on the reader and grounded in the controller as well, then you don't really have a shielded wire. So make sure that you're grounding that wire, connecting it to the reader properly, and as you do so, you'll have a properly grounded and properly shielded wire for your reader. It really is going to save you from a lot of headaches on that one door that's not working, or again, longer run lengths that may be crossing high voltage wires, and you may run into errant information that's coming into your wires. So the last thing I want to point, if I come to the slide here, is the distance of wire that you can run. So if you're running an 18 gauge wire, you can run typically 500 feet. If you're running a 22 gauge wire, you can get about 250 feet. So again, make sure that you're looking at the type of wire that you're running. And let me just see what this is here. This is a 22 gauge wire here, so you're going to get about 250 feet. And that's very typical that your reader wire is 22 gauge wire. It's not very typical that it's 18 gauge. So if you need to get additional distance, then I would move to an 18 gauge wire, but most wire that's provided for readers is in your 22 gauge and is going to give you roughly 250 feet. But again, make sure that it is shielded wire. It's going to save you a lot of headaches. So let's look at a wiring video on how to wire a reader. So if you see, we've got these pre-stripped. They're stripped just under 1/4 of an inch so that they can go into the connectors. I've got an extra wire that I'm just going to loop back here. I always leave the extra wire and clip it off because you never know if you might need that down the road. So if you don't need it, tuck it back, put a little piece of tape on it or something like that, make it look nice. And then you're going to, again, find that I've got my plus, which is, again, my positive, which is the red wire. That's providing the reader with positive voltage, DC. And again, readers are typically between 9 and about 15 volts DC. I've got my black wire, which is my negative. So now my reader will have power. My next wire is going to be green, which is data 0. And I always remember that by green O and white 1. So if you're looking at data 1 and 0, if you look at computers, right, data 1, data 0. And again, if you're looking at your data 1 and data 0, they're not oscillating between each other. They're actually oscillating with that negative wire. So your ground on the, and then my last wire I'm putting in here is the brown wire, which is my trigger for the LED. So again, when I scan and I'm allowed, it's going to change the LED from red to green and hold that for as long as the door is unlocked and open. So if I put that door on auto open, it's going to continue to trigger that. And it's actually oscillating, or sorry, not oscillating, but connecting that wire for the LED trigger to a ground. So if you were to take that LED trigger and just touch it to a ground on your controller, it would change the color of the LED from red to green. So when we provide an allowed on a controller, it's merely pulling that to ground and turning that LED green. So it's the same thing with the buzzer on the reader. The buzzer positive is pre-connected on the internal guts of the reader. You're going to take the ground wire. So if you were to take that piezo wire for the reader and touch it to any ground, it's going to start to go off. So when you put that into a relay, because you want to get a piezo to go off when a door is propped, you'd set up that rule. The relay is going to pull that to ground and make the piezo on the reader be triggered. So again, most things on a reader are pulled to ground and trigger whatever the feature it is that's available on there. That's important to note as you navigate different types of installations. But if you look at the data 1 and data 0, coming back to that, is again, they don't toggle between each other to provide data 1 and 0 to the controller. They're actually toggling between the ground that's connected to the controller. So you've got your positive and your negative. So if I have that connected, the negative connected to the controller, it's going to toggle my one between negative and my 0 between negative. So what I've seen in the past is if you have a separate power supply, I've seen individuals take that power for the reader and run it to the separate power supply that might be sitting right next to it and not connect it to the controller. If that ground is not shared with the controller, then you will not get card reads, or the card reads will come back falsely because it can't toggle data 1 and data 0 for the reader. So that's important to know if you ever get out to a job and you say, man, why am I not getting card reads? And you connected that power to a different power supply or something that's not connected to that controller, that will be one of the issues that you might want to look at. So reader connectivity is very important. Let's look at your lock and your locking wire. Okay, your locking wire is typically going to be a 16 or 18 gauge wire. It's two conductor, and you typically have a positive and a negative, or a red and a black cable like you see here. And your typical run length on that is going to be 350 feet. So as you're powering your devices, again, keep in mind how much amperage you're pulling. Look at your calculators. Make sure that if you do have line loss, you may be able to make up some of that difference by increasing the gauge of that wire. But if you can't, then make sure that your run length isn't superseding, and that you provide enough power to that wire so that if you do have some line loss, you're not affecting the devices on the other end. All right? And again, sometimes voltage will make up the difference, like we talked about in the power course. So you want to just be cautious with pulling too much power, and make sure you're looking at line loss calculators so you don't underpower your locking hardware, whether that be a strike or a maglock. There's nothing you can do that's more detrimental to a piece of hardware than underpowering that. That's why you always see on a device that it has a low voltage rating and a high voltage rating, so you don't underpower it. In the instance of a reader like we talked about, it's got 9 volts up to maybe 15 volts depending on the reader. You're always going to be better being in that 12 and 13 volts, but just know that if you happen to be at 10 volts and it is rated at 9 on the bottom side of that, you're going to be just fine. You're not underpowering it unless you get below that 9 volts. And then again, make sure you're looking at the amperage as well and your other devices so that you're not underpowering other devices. So again, 350 feet. I'm going to show you a little video on wiring up a DPS. So DPS will also utilize a 2-conductor wire like you see here. A lot of times, let's see if I can get it to focus on it. A lot of times this is 22 gauge for a DPS, but in many cases it could be 16 gauge as well. So on a DPS wire, you're going to find it's typically a red and a black wire. It's, again, very typical. There's not a positive and a negative, although you will tie one side of the DPS into negative for PDK. Other types of controllers may handle this a little bit differently, but most of them, it's just providing a ground loop based on whether that door is open or closed. So if you look at a door position sensor, it's a security contact, and it just has a little read in there. When the door closes, the maglock hits that, or sorry, not the maglock, but the magnet for that door contact gets close enough that it pulls that read into the closed position and closes the circuit and lets the door controller know that that's closed. So if you look at the connectivity here, I've got the positive wire, the red wire, into my DPS input, and then I've got that negative wire connected into a ground. So on the other end of that, I've got it connected to a door position sensor. When that door is closed, the read comes up because the magnet at the top of the door, as soon as the door closes, brings that read and pulls it into the closed position and makes a ground loop. So the door controller now knows that the door is closed. And when that door is open, that read pops back open and breaks that connectivity. Now there are different types of door position sensors out there, but that's the most common. they do make an open scenario as well, where it actually acts in the opposite of that. Also, they make what they call a double throw or a double pull connectivity as well. So if you've got a security system in place as well, there's no need to put 2 or 3 different door contacts on a door to monitor the door position of that particular door. There are some ways you can do that through the access control system, which is pretty unique when you look at PDK. And you'd have to look at other manufacturers if you're installing a different brand on if that's possible. But if you are installing an intrusion system and an access control system, in most cases, there's no need to put 2 door contacts. Go and buy a double pull, double throw door contact, and it's got 2 contacts inside of that. So when the door closes, you can have your access control connected to it, as well as your intrusion device connected to it as well. You've got 1 door contact and looks really clean. But again, it's looking for a loop on your ground to pull that. So it does have to share the same ground as is on your door controller itself. Now I want to look at what we call banana cable. And many of you that have been in the industry for a long time have seen this. It's a very thick cable, has many different wires inside of it that provide connectivity to all of your devices at the door. Now I see many individuals out there that utilize Cat 5 or Cat 6 to run to a door. It's got a lot of cables in there. And so all of these wires now I can connect to my strike, my door position sensor, and it just makes it super easy. But I can promise you every single time without fail, you're going to run into issues by trying to run shortcuts like that. So make sure that you're never connecting readers, door locking hardware, or anything like that using Cat 5 or Cat 6 just because you have it on the truck or because it's 10 cents a foot and it's a much less expensive wire run. It will never make sense to do that. And you'll run into support calls over and over and over again. So make sure that you're running, again, the proper wire. But I would say if you look at this slide, always make sure that you're being consistent. Consistency wins every single time. If you're not consistent, what you're going to run into is one of your colleagues going out to a project that you installed and finding out that they don't know how to troubleshoot a specific door because they don't know how you wired it. You either wired it with Cat 5 or Cat 6, which should never be done, or you've ran individual strands to a door. And so I've seen it also where they'll take reader wire, and so you have reader wire on your truck, you don't have any other wire, so you run one of those to your Rex, you run one to the door locking hardware, and you run one to the reader location as well. And so now you're using all the same wire. You go back to the controller and you've just got this wire mess because you don't know what's connected to what. In most cases, you've got the wrong gauge wire running to all of those devices, certainly your locking hardware. And in most cases, it never saves you money and it never saves you time. So being consistent, in my opinion, always running a banana cable or a braided cable for your access control is a win every single time because consistency wins. Even if you're not going to utilize all of the wires that are available in there. Now this banana cable runs anywhere from 50 cents. Even I just bought some of this Plenum stuff to show you, and it ran about 70 cents a foot. So by the time you take all the individual strands and calculate them, number one, you're not saving time. You're always going to be better off, even though this has a few additional cables in there that you might not be running or utilizing on a specific door. That's a simple installation. It's always going to be best to be consistent. So use banana cable. Let me come back to the slide here. You'll see that locking power is, again, typically 18.4, door contacts 22.2, request to exit 22.4, and a reader is 22.6. And that's typically what's provided to you in the banana cable. And you saw the banana cable on the slide, but I've got a piece of it here that's stripped back for you. And you'll also see this little thread here on the side. And I had somebody the other day, as I took this thread and started pulling it back, and it strips the outer coating off of it. So once you get to the door and you pull this banana cable, while you're at the door, you may need to pull it back quite a ways so that you can run down to the reader and then to the locking hardware and split that wire. This is a really nice way for those of you that might not be familiar with banana cable or the individual strands. They all have this little piece of thread inside, this nylon, that allows you to just grab it and peel that wire back. Makes it extremely simple. I can't tell you the number of times I've seen individuals take this wire and just take a razor blade and try to slice it down the side, when you can take this and just pull it and you'll strip that wire all the way down. And again, all the individual strands also have that functionality in them. You can grab that and just strip it down as long as you need. And I'm a huge fan of typically stripping these about 2.5 inches, so you've got enough wire to run. And as you're looking at wiring your REX, your door position sensor, your locking hardware, and any other devices that you have at the door, all of this now is running directly back to your controller. So if you need to butt connect some wires together, utilizing bean clips or any other sort of connectivity, you'll be able to do that right inside of the controller. So you're not bean clipping a bunch of wires at the door. So again, when you go there to service a specific door, you're not having to pull panels off at the door to try to understand how everything is wired. You have everything ran back to the controller, and as you're at the controller, you can take each one of these wires, and again, through consistency, you'll know how it's wired. I saw a company that did something fantastic. I was a huge fan of it. They essentially took the banana cable and they took a picture of it and they put it on an 8.5 by 11 that was laminated, and they had it connected to the different types of devices at a door. So they created this real consistent message amongst all of the installers in the field on how you wire each different type of door scenario. So now if all I have is a reader, locking hardware, and I don't have a request to exit, it's going to be wired this way. If it's a door that's only an auto open style door, doesn't even have a reader on it, it's going to be wired another way. If it's got all of the devices, including a request to exit, then I may wire it this way. Or when utilizing a mag lock versus a a strike or some other electronic hardware, I'm going to wire it another way. So it's not something that that's very, very difficult, and I would strongly recommend, at whatever the size of your company or organization, is to provide a sheet on the consistent wiring methods for your organization. So if you're pulling banana cable, you get back to the controller, boom, this is how we wire these specific scenarios up. You'll find consistency. Your support calls are going to be significantly easier, and every person within the organization is going to be on the same page and understand how individual devices are wired up. So if you remember one thing from this training, consistency is key. I'm a huge fan of the banana cable or braided cable. Make sure that you're running that. It has every wire that you need in there and more. So very important. And you'll notice that your reader wire is shielded as well. So it's that shielded wire is taken care of for you. The one thing that I noted a little bit earlier, but I didn't talk about, is the difference in plenum cable and non-plenum. Well, if you could see the ceiling here, this ceiling above us is a plenum rated ceiling. In other words, the return for the HVAC is actually being pulled from the air that's above the ceiling tiles. So you see vents in the ceiling tiles, but these vents are just open vents up to that plenum area. And the HVAC units, or the fan units up there, are just sucking air from the general area above the drop ceiling. So the reason that that's so important is when you're utilizing plenum cable, the plenum cable in a fire scenario will burn much differently than a non-plenum cable. So if you're running it in a plenum area, most fire inspectors will look for that. And if they don't, shame on them. It's very important. So I'm a huge fan of just running plenum cable, especially if you know that it's a drop ceiling or it could possibly be a plenum area. If it's not sucking air from that area, then it's typically not a plenum. So if it's got a return duct that's ducted directly to the main area, then that typically is not a plenum area. So you can find out from the GC whether it's going to be plenum or not if you can't just see what it is from visual inspection or if it's a new build. So make sure that you look to see whether it's plenum or not, and make sure that the cable that you're running is plenum cable if it's a plenum style installation above the drop ceiling. That's very important. So the last thing I want to show here is coming back to my Rex, my maglock, or my strike. This particular wiring video is going to be for a maglock with a request to exit device, and showing PDK's method of wiring it. It may be a little bit different on different types of access control panels, but let me show you this video on how we wire them. So if you look at the wire that's coming in for the maglock, in this case, you're going to see a positive and negative, okay? So if I were to connect that directly to a positive and negative, it would immediately lock up that maglock. So what we're going to do in this scenario, if you look at our quick start guides, is I take my positive and I wire it directly into a positive. So now that maglock is receiving a consistent positive voltage. And I know many of you may break positive versus negative, and you would just put this in the opposite wiring method. All right, now you see that I've got my Rex wires coming in, and for my Rex, I'm going to have a positive and negative if I've got a powered Rex, which motion Rexes are powered, as well as you'll see the powered buttons. So if I push a button and that button is illuminated or has a timer built into it, that's going to be powered as well. So most Rexes should be powered, and you want to make sure that it has a timer built into it. So you're going to see right here that he's taking the negative and he's butt connecting that to the common on the Rex. And again, I'm doing that inside the controller, not at the maglock or at the Rex, so that my support on this in the future is much easier. I'm going to disconnect the positive, and again, this could go into any positive. So on our controllers, you can fit 3 wires in there, no problem. If you need to run it into any other positive, you can do that. So that's how I'm going to power the request to exit. So now I've got the positive for the maglock, I've got the power for the request to exit. I'm going to disconnect the negative. And that's my DPS is running into that negative. And I'm going to run the negative for the Rex into that negative. So now what that's doing is it's powering my Rex and providing positive to the maglock as well. I can plug that back in. And now I've got the negative connected to the common on the request to exit. And you'll see this in our quick start guide. Now the other wire that I'm connecting right here is the normally open wire, and that's being connected to the Rex trigger input. So in other words, when that Rex triggers, it's going to get a ground loop that comes through and lets the board know that that Rex was triggered. So I can get a forced door open if I want to utilize that feature. And then you'll see the normally closed wire, which is this black wire, is going to go into the normally closed on, so that's the normally closed on the Rex coming into the normally closed on the door controller. So you're just making this ground loop all the way around. In other words, if the Rex sees motion or the button is pressed, then it's going to cut ground to the maglock. If you trigger an allow on the controller, it's going to cut power to the maglock as well and open that up. The last thing that you saw in there was a little jumper. On our door controllers, we don't require that you bring negative or positive into the common on the controller itself. You can actually jumper positive or negative directly from board power onto the controller itself. So it's a really nice feature to save you a little bit of time as you're doing your wiring. So last things I want to show you here, which I think are most important, are what we call engineering or riser diagrams. These are absolutely phenomenal based on the type of product that you're installing. So if I'm installing a cloud node or a door controller, this tells you exactly what your connectivity is going to be, the different type of wire that's required for those particular ancillary devices and for communication. So you never can go wrong on how you're powering devices and how you're connecting to them. So if you look at my cloud node, you'll notice that I can power the cloud node from the provided ProdataKey power transformer, or I can use a high voltage converter, which is provided by ProdataKey, and either one of these can run into the cloud node and provide power to the cloud node. Now my network connectivity is going to happen by Cat5 or Cat6, connected directly to a network switch, okay? And then if I look at my door controller is connected, if I'm utilizing a network-based door controller, by Cat5, Cat5e, or Cat6 back to the network switch. And my network switch is connected to the internet, and that's how my cloud node is receiving internet connectivity for the cloud. Then if you look at your ancillary devices, if I look at my door position sensor, it's showing a 22.2 standard cable. Stranded cable. If I look at my reader is a 22.5 stranded. And again, it says shielded is recommended. If you're running a banana cable, it comes included. If I look at an 18.2 stranded, that's to my locking hardware. Now that can be a strike or it could be a mag lock. And again, is provided inside of that banana cable. So this is going to mean a little bit less if you're using access control braided cable, because it's going to come with the proper gauge wire. Then if you look at how do I power my single door controller? Well, I have the option to utilize the included transformer if there's a very close 120 plug-in, or I can utilize a high voltage power supply. And the other thing that's not shown here, you can use just a standard access control power supply that you might get from Ultronics, as long as it's providing enough amperage and voltage for your door controller. So these riser diagrams are absolutely invaluable. This particular one here is for a network-based controller. You can see one here for an 8-door controller, okay? And it's showing that these wire lengths might be a little bit longer. This one here is for a gate controller and connected back to a cloud node. So make sure that you're looking at the different types of riser diagrams and understand that different types of devices are going to utilize the different types of wire and may have different types of wiring configuration. But if you're looking at those riser diagrams, you can never go wrong. So my suggestion is that on every truck or every van that you should have a couple of things. You should have a calculator that's showing you your wire lengths, battery calculations, etc. You should also have a laminated sheet that shows the different types of devices that you could be connecting at a door and how those devices are physically wired together. And again, I would show that in almost a wiring diagram form on an 8.5 by 11 sheet. Then the last thing that I would have are these riser diagrams showing how these devices intercommunicate and how they're connected based on the type of access control platform that you're installing. If you have those types of devices, you can't help but be consistent on every project that you're doing and really have a great experience internally as you install and as you support. But also your end customer is going to have a fantastic experience. And as you look at your wiring's going to be a lot cleaner because you're going to be a lot more consistent. So keep that in mind. There are a lot more things that we can go into from a wiring perspective. I saw something that I really liked, and it's not something that I did in an installation, but I saw a company when they were utilizing quite a few different 8-door controllers or multiple controllers from a different manufacturer. They may put a wiring tray right above that's an open canister that you can run and do your wire loops in those canisters and then run your conduit down to the different controllers if you're centralizing all your access control into a specific room. So it makes your wiring look very clean. You can have a little bit, some extra loop of wire inside of that cable box. And then you put a cover over it. It looks very clean. And then down at your controllers, you strip your wires all the way down inside your 8-door controller, and you can run some really nice 90s into each one of the ports as you're connecting those. I would strongly suggest against zip tying every single small wire as you're connecting it into the controller, unless you do it in a way that will allow you to support and manage those particular ports or those doors that you've installed. If you can't, and every time you go in to manage or provide support on it, and you've got to cut all those zip ties, there's not a ton of value to wire management that way. So do wire management, make it look really clean. Your customer, I would strongly suggest taking your customer through it, show them the installation. Your customer is going to be one of your best sales methods, recommending other jobs to you. So if you can bring them in there and show them, hey, just so you're aware, I want to show you the installation, not only at the door, but also back in the closet, even though it's not something that people are going to see, and be proud of the installation that you do. And then do your cable management properly so that you can best support that door down the road. And I always strongly suggest, whether it's a door that you're installing that's an edge device, or a door controller that's at the door, or centralized, that you have a little additional wire in case you need to move some things around or change things up. So I really appreciate your time, and I hope that you found some value, or at least some really strong tips and tricks on how you can better manage your wiring. And if you didn't understand wiring before, I hope that you found value in this. It's a lot of great information and things that I learned in the many years that I've experienced on the installation side, as well as working with a lot of installers throughout the industry. So I was really excited to deliver that to you. I want to go through a Q&A, but before I do that, I want to show you our sales certification. So for those of you that might be more into or more geared towards the sales side, make sure that you join our sales certifications. We have these every other week. They're done by our sales team. They're fantastic. They help you understand how to do job walks, how to quote products out, and the tools that are necessary to sell ProdataKey. Also, if you look at our PDK technical or certification, that's going to show you particularly how to install our personal product. So if you're interested in ProdataKey, make sure you go to ProdataKey.com and register for the sales or technical certification, and you'll understand how to be successful doing technical sales. So let's move on to the Q&A and see what types of questions that we've got. What type of wire strippers do I find to be most valuable? That's a good question. I'm a huge fan of just these basic. I get these just at Home Depot, but I know many distributors carry them. But it's a commercial electric. There are some that are a little bit longer that I like a little bit more than these. But almost every wire gauge that you're going to have in access control, it's very easy to hit that wire without nicking the internal cables and strip it back. I've also utilized for several years the small ones that really are controlled by you. And I don't have them here today, but it just has one little V in it. So any size cable, if you get really good at utilizing them, you can just use them on any cable, and it's really done by feel. So you can strip cables really fast. You don't need to use the different gauge, the little gauge selectors here on the different types of gauge wires. So again, if you want to be super accurate, I would utilize something like this. If you're really good at feel, then I would suggest getting the little V-neck strippers that you can just get feel, throw them on there, you can spin them around, pop your sheathing off, and you can utilize them with any size wire, and it strips them very easy. But for the first little while, as you get used to them, you may struggle a little bit, and you may clip some of those wires in there. So as you're looking at utilizing stranded cable, which is the type of cable that you should use, each one of those has many different strands inside of it. So if you clip it incorrectly, you could actually clip some of the strands off and affect the amount of amperage or wattage that you're pulling through those wires. So just be cautious as you're utilizing different types of wire strippers. So I appreciate your time. Thank you so much for everything that you do. It looks like we may have Another question here. Can you touch on diodes real quick? Oh yeah, absolutely. So diodes are extremely important when you're utilizing a strike. It's not very important when you're utilizing a maglock. The maglock has some diodes built into it, but it also acts as a diode or a suppressor because it's energizing and de-energizing with a coil. With a strike, the coil is much smaller, and you typically see that throw happen very quickly. So if I've got a strike installed, it maybe has 7000 strike, it's one of my favorite strikes. When it unlocks, you're typically not going to have any issues. The issue that you're going to run into is when that strike locks back up, you can get about 700 volts or so of errant voltage that comes through. It's at like 0 amps, so there's no amperage to it or no bite. But what can happen on different types of controllers, on a PDK controller, you'll typically see an errant card read. So you'll just get errant information in the controller itself. And if you're on a different type of controller, I've heard of other brands that it'll actually even lock up the controller because it doesn't know what to do with that errant voltage that's coming into the controller. So what a diode does is you're going to place the diode. Let me just grab this. And again, I've got two sides of the same wire, but just imagine that one of these is your wire coming from the strike and the other one is coming from the controller. What you're going to do is connect your positive and your negative, and you're going to put your diode directly between this positive and negative. And I actually don't remember, it's been long enough. Stripe goes to positive. So if you have the diode that comes in every one of our controllers, the stripe side of your diode is just going to butt connect. So I usually take my positive, I'll put them together here, and then I'll put the end of the diode, put a bean connector, and then I'll take my negative, put those together, put the other side of the diode in, put a bean connector on it, and then I'll lay the diode flat and just put a little piece of tape so that you don't have bare wire sticking out. Or I always really liked just keeping a whole pack of shrink wrap, and so I just throw a little piece on there and hit it with a little torch. It looked very, very clean. It's up to you how you do that, but a diode is very, very important to suppress that voltage that's coming back through the line to the controller when utilizing a strike scenario, and almost every strike is going to do that. So just be cautious. Again, on maglocks, we don't run into issues. I have seen it in one or two scenarios in the past, but would you install a diode on a maglock? I would say no, but I would always install it on a strike or an electronic locking hardware that acts similar to a strike. And most locking hardware will tell you if it needs a diode or some sort of suppression device on it, and maglocks don't typically illustrate that. Let's see if there's anything else. On the cloud node, what is the antenna used for if the Ethernet cable is connected to the network? I may have missed. That's a really good question. I've got the wire for the mic hanging out of my sleeve here. Let me just pull that back. So if you look at the antenna on the cloud node is only utilized to communicate to wireless door controllers. So there is some resistance that happens in that antenna connection. So we always require that you take the antenna and put it on there regardless of if you're utilizing wireless door controllers or not. It's a proprietary wireless signal, so you don't have to worry about anything else connecting to it, but always put the antenna on there. If you're utilizing wireless door controllers, which we also sell in conjunction with network or PoE door controllers, if you need one as a solution to a problem, maybe you can't get to a door with wire, you can certainly utilize a wireless door controller, and that will connect directly back to that wireless antenna. So the cloud node comes with Ethernet and wireless connectivity built onto it. So no matter what type of controller that you use, it comes capable of connecting to any type of controller that you might be using. Very good question. Well, thank you so much. I sure appreciate all of your questions, and I appreciate your time. Again, this is very valuable data. It's important information that I wish that I would have known the first time that I installed. I remember spending 4 to 6 hours on a door just trying to figure it out. And my installations didn't always look real pretty in the first couple of months, and it took me a long time to really understand how do you be consistent and how do you install properly so that you give a great experience to your customer again. So one of our mission statements is to create trust within our organization. You can do the same by trusting each other, trust that you're going to have this consistency, but also create some great trust and some great value to your customers that you're installing for. As you do so, I can promise you that you're going to find a significant increase in recommended or referral business, and that goes a long way. So a lot of times as a tech, when you're out there installing, when I was out there doing the installations, you don't always think that the work that you're doing behind the scenes will affect the business long term. But it 100% affects your business from a support perspective, and it also affects the overall business from a sales perspective as well. Because these customers will not only continue to come back to you because they trust the quality of work that you do, but they will recommend and refer you to other people because you're not going to have as many callbacks on a job. And when they go look at your work, they're going to look at a work of art. You should look at that every time. Thank you so much for your time, and we look forward to seeing you on our sales and technical certifications. Take care.